In the previous section, we see that basic blacklisting and whitelisting won't be sufficient because of these bypasses. Now, let's take a look on what these bypasses are. Basic blacklisting and whitelisting can be bypassed by using several methods. Some of these methods are URL shortening, domain redirection, alternative IP representations, and URI normalization. Let's take a look on what URL shortening is. URL shortening is the process of shortening lengthy URLs so that it can be easily sendable to others. Since URL shortening hides the original URL, a person clicking the shortened URL has no idea on where he will be redirected to upon clicking the URL. Here is an example of how URL shortening is used to bypass filters. Assuming there is a website called site.com. Site.com disallows or blacklists the use of the domain attacker.com. Using URL shortening from tinyurl.com, the attacker can rewrite this URL to this, which bypasses the filter since the domain tinyurl.com is not included in the blacklisted domains. Now, let's see what domain redirection is. Domain redirection is similar to URL forwarding, and this is also called URL spoofing. Let's say the IP 127.0.0.1 is blacklisted. An attacker will buy a domain name from domain name providers such as GoDaddy or Namecheap, and he will configure that domain to point to the 127.0.0.1, which is the blacklisted IP. Here, the attacker bought the domain of localtest.me. Checking the localtest.me using the dig command, we can see that the IP address that the localtest.me is pointing to is 127.0.0.1. This means that if we open the localtest.me, we will be redirected to 127.0.0.1. And this is how attackers can bypass blacklisting and whitelisting. They will buy a non-blacklisted domain and will point it to the blacklisted domain. For the next one, let's take a look on the alternative IP representations. We all know that we can access a website by typing its IP address. For example, we can open google.com by simply typing 142.250.199.78 in our browser's address bar. This is the basic of IP representation, but most of us are not aware of the alternative IP representations. The HTTP://142.250.199.78 can be rewritten in many ways. Some of them are as follows: the decimal notation, the octal notation, hexadecimal notation, full hexadecimal notation, full octal, and then the random notation, which is composed of 2 bytes decimal and 2 bytes octal, then the random notation that is composed of hex, an octal, and 2 decimals for the last bytes. Aside from that, there are also some of the additional IP representations. The first one is in hexadecimal notation that has random padding, and the next one is in octal notation with random padding as well. The next two ones are IPv6/IPv4 address embedding, and the last one is IP address overflow, where the 51,022 is just 199 times 256 plus 78, which are the last 2 bytes of the Google's IP address. Aside from this, there are also other ways that involve incomplete IP address. If you have a URI of HTTP 1.0.0.1, this can be rewritten as the following: http://1.1 and http://1.0.1. Whew, that's a lot to take in. But we're not finished yet. Let's take a look on how URI normalization works. URI normalization is a browser process in which it converts non-normalized URLs to a proper one that satisfies the RFC standards or the request for comments. Here's an example. Have you ever typed google.com in all caps? Even after that, the URL is properly rewritten by the browser and converted it automatically to lowercase, and we are redirected still to google.com. That is URI normalization in action. But URI normalization is not that always simple, because all of these URLs are also normalized to be google.com. So in summary, URI normalization converts all characters to lowercase and converts also some of the Unicode characters to their equivalent alphabet ones. We can see here that there's a lot of bypasses, but we will only try to implement a code that handles only the last two bypasses, the alternative IP addresses and the URI normalization. This is because the URL shortening in the domain redirection is very hard to check. Why? Because we can shorten a URL for 100 times. We can also implement a domain redirection for 100 times as well, making it very hard to validate. Even Facebook's URL validation only implements checking on the alternative IP addresses and URI normalizations.